Help with the recording. Well, let me welcome you all to the first of these Gorman lectures. We already had an exciting afternoon with talks. Make sure you take your jackets off. I know it's a little bit warm. We try to alert the maintenance, but hopefully they'll act on it soon. The only thing that I wanted to do here is to mention that actually Ariel is visiting the economics department until early July. So if you're interested in talking to Ariel, please reach out to him. And the other thing I'm going to do is to introduce who's going to be Richard. He's going to say a few words about Ariel.
Eventually we get to Ariel. Thanks, Ariel, I was going to say, for fantastic organizing this whole event, including this wonderful conference we've been having. But it's a pleasure to introduce this year's Gorman lecturer, Ariel Pakes. Gorman lectures began in 2001, and we've had a string of amazing people giving these lectures from, I think Jim Heckman was the first, 2001, and then through Dan McFadden, Jean Thoreau, Tom Sargent, Claudia Goldin. He goes on, I won't let you. But if you think of 2001, of course, this makes it our 25th anniversary Gorman lectures. So this is a very important one. Ariel is Thomas Professor of Economics at Harvard. And it's really fitting that he's here to do these Gorman lectures. They're named after W.M. Gorman, otherwise known as Terence, who some of you may remember, but probably only a few of you now. He was a visiting professor here from 86 to 96. And you could say that may seem a long time ago, which it is, but it was a period that transformed the department at UCL. And Gorman was a key part of making that transformation happen. So, it's kind of in that memory that we set up these lectures, because he passed away early in the 2000s, earlier than he probably should. So the point about Gorman is his approach to economics, about bringing theory and data together with appropriate econometric techniques. And you can see that how that's aligned with the way we try to run, I think, the department at UCL, to give equal weight to econometrics theory, applied micro and macroeconomics, so across the breadth of economics, and to do it in a way that's avoided separation into silos as much as possible. That's even better, of course, if it materializes in one person, like Gorman did. But it also describes the way Ariel approaches his work. Indeed, Ariel goes much further. He's made, as many of you know, frontier contributions in econometrics, empirical micro, and IO theory. He has a huge number of highly cited influential papers. So I thought of a few hits that came to my mind. I double checked Google Scholar, and we're kind of pretty much aligned there. Let me just remind you of a few. Of course, the one we often think about is the 1995 Econometrica paper with Steve Berry, James Levinson, on the automobile prices and market equilibrium, otherwise known as VLP. And what they did there, of course, we know now, is how to estimate demand, differentiated products, allowing for endogeneity prices. It was pretty much a remarkable breakthrough. There are numerous applications. It's not just the standard in academia, it's now the standard in industry itself. In fact, Ariel quit the other day that he was sad he didn't patent VLP. We have a slightly different view. We're pleased you didn't, and you didn't get rich out of that, because we all know about the wealth effect. And we wouldn't have had that set of wonderful papers. One of them being another great hit, which was Ollie Pakes, the paper with Steve Ollie in econometrics, on econometrica again, on the dynamics of productivity in the telecommunications equipment industry. Again, a breakthrough paper. As usual with Ariel, there's a really kind of, once you've seen it, really simple, fantastic point. And the wonderful insight there is just how you might learn about productivity by using first order conditions. bring them together with production function. It's had an incredible impact on the measurement of productivity. We'll probably hear some of that here. It's pretty much the standard reference. The one I kind of thought of that I remember happening as well was the simulation model. It affected the way I did stuff, and it's the simulation and the asymptotics of optimizing estimators for followed, I guess. And that was again driven by a kind of need to do something, i.e. the models were pretty complicated, unobservables were inside nonlinear functions, and you had to do something. We see it all the time now, simulation estimators. It's kind of two big names there. There's Dan's work, Dan McFadden's work, and Ariel's work. I remember it particularly here because I remember my young colleague at the time, Costas McGeer, getting super excited and within about a year published a paper using it. So it's stuck in my mind. But perhaps the kind of fourth big hit in my mind is the Frisch Prize paper from way back in 1985, I think, again in Econometrica. It's on patents and options, which is a terrific paper. It was kind of one of the first I saw where dynamics is introduced for good reason, not just to make it fancy. You know, you can't solve a model with that kind of discreteness and uncertainty and make any headway with it unless you introduce dynamics. And that was a kind of key insight there, and it's had a remarkable effect. I guess the Markov Perfect Industry Dynamics paper is probably the kind of theory paper alongside that we heard a lot of in the conference today. Anyway, there's much more. Recently, there's the work on health and pharmaceutical industry. We'll probably hear some of that. So what characterizes Ariel's work? Well, a really deep knowledge of the market. You have to do that. Talking to Ariel, that's the first thing that motivates him. What does the market look like? And I'm sure we'll see a bit of that. The other thing is what counterfactual are you trying to recover? And then, of course, the use of frontier econometrics, and naturally develop some of those if they're not around the use of theory. But probably more than all of that is just a love for developing students and enthusiasm for work. The first thing that happens when I arrive in the department, you come to your room and it's intense and exciting and fun. And we're very pleased that you're visiting for this over this period. Ariel's had a lot of awards, not just the Gorman Lectures, fellow Econometric Society, National Academy, Frisch Prize, Nemers Prize, Font Prize, I could go on. But Ariel's been a real true friend of the department and to IFS, where he's visited many times. We always learn a lot. In fact, he was here 20 years ago for the Fisher-Schultz lecture, I think, at the 2005 World Congress, which depressingly is coming up to 20 years ago, but now back for the Gorman Lectures. So let's welcome Ariel for the 25th anniversary lecture.
I think people can hear me. If you can't, you should say something. Thanks very much for inviting me for the lectures. It's a great honor. And thanks for sticking around to 6 o'clock to listen to a lecture. I'm going to take off my sport jacket now that I've introduced myself and try and keep it going. I hope I get this right. So I wanted to start with a little bit on Terence's impact on structural and empirical work. I knew Terence a little bit. At least the part of Terence's work that I knew best was his work on demand systems. And as many of you know, demand systems are sort of the heart of much of structural empirical work. You need a demand system for incentives. I think this characterizes the way he approached it. He said, look, how can we estimate demand for a large number of goods with a small number of parameters? That was the fundamental question. In IO, you frequently have 100 products that are competing with each other. If you did, 100 prices on one side and 100 quantities on one side, 100 prices on the other, 100 times, that's 10,000. You're never going to estimate that. And the same thing happens in different ways in more aggregate work like public finance. So Terence did two things. The first thing he did what's called what I call Terence's polar forms. Okay. And they're usually called Gorman's polar forms. He gave necessary and sufficient condition for multi-stage budgeting. What's multi-stage budgeting? I budget, drive time for something. I budget some, I budget in groups. Okay. It's used intensively when you want to have aggregates, when you're dealing with big aggregates. Unfortunately, so it had a huge impact. So, the almost ideal demand system is, it started there. Okay. It wasn't very useful in differentiated product environments because, which is integral to industrial organization. And the reason was there wasn't sufficient differentiation in cross price elasticities because some goods are closer to other goods and we needed that to estimate things and analyze things. So I talked to Terence several times, but I didn't have the presence of mind to see through this, okay, at the time. But either way, I like to think that this is why he did it. But he actually wrote this paper at the Iowa State College of Agriculture. You young people don't realize this, but agriculture was where data was in the United States. So people did a lot of the work at agriculture research stations, okay? So what he wrote in his paper, a possible procedure for analyzing the quality differentials in the egg market. It was written in 1956. Mervyn King republished it in 1980 in Restad because it never got published. Okay, this was probably the closest paper I know as forerunner to BLP. Okay, he did everything in characteristic space, just like we did everything in character, and so on. Okay, so actually, both multi-level demand system and characteristic BLP and others and fellow travelers, okay, are by now well understood. I'm not really going to talk about them in the lecture. Okay. So there's a sense in which the lectures will follow what Terence did. What Terence did is what he was very concerned with the integration of economic theory and empirical work. Okay, this is what drove him, and I talked to him several times about this. So there's going to be a lot here, and it's like that. Okay. The lecture is going to begin with some notes on the empirical work that I did, which foreshadowed a lot of the things I did subsequently. Okay, what raised questions on things that I went before. Now I'm going to turn to two of many topics that have made dynamic counterfactual analysis difficult. There are partial solutions to problems, but it's not finished. What they have in common, that these two things have, one is on more the way consumers choose things. And one is more how markets evolve. Okay, so the second lecture tomorrow is on how markets evolve. Today it won't be there. Okay. The thing that's common between them is there are two models which relax cognitive requirements on individuals. Okay, they're going to be maximizing models just like normal stuff. But they're going to relax the cognitive requirement, what I need to know in order to make a good decision. Okay, that's the goal. Okay, both of them are that goal. This thing, Terence, I like to say this, but Terence, the other people who were doing this at the time was also the Coles Commission. So that was the other predecessor. I like this comment very well. Actually, Chuck Massey gave me this comment. So the Coles Commission, Havelow was the first Nobel Prize winner from the Coles Commission. There were many thereafter. And he has this 120-page paper in Econometrica, which you probably don't want to read. But it starts out with this comment. The method of econometric research is essentially at a conjunction of economic theory and actual measurements, using the theory and technique of statistical inference as the bridge pair. That's very much what structural work is trying to do. So I'm going to argue that empirical work, I'm not going to really argue this, but I'm going to say it. Empirical work in IO organization took Terence and Coles really seriously after the 1990s. Okay? And I think much of the profession is coming along. Maybe they don't think they're coming along. Maybe they think they're out front. But But, you know, it was facilitated by other things. I just want to keep that, you should keep that in mind. There were prior developments in theory, both in econometric theory and in economic theory. And actually, one of the two things I'm going to focus on is because of it's able to do, it's an old problem that I can do now because of new econometrics, not by me, by others, but I'm implementing new econometrics, okay? And the other one is new theory, okay? So it's both. So one thing is the prior, the other thing that helped us a lot was the increased availability of computer power. Okay, this was a huge deal. It's not only for the use of computational power, it's because it generated a ton of data. Okay, and we use it all the time. And then I think the third thing that started all this is there's no credible alternative way of analyzing a counterfactual environment. Counterfactuals aren't in the data. You've changed the data. You need theory in order to analyze a counterfactual. You can't do it without theory. And so people got interested in policy questions. And in policy questions, you want to try and get some answer before you actually implement the policy, because they're expensive to implement and take a lot of time. Okay, so that's the third thing. Okay, that's it. I'm going to start now with this old paper that Richard talked about. It's all in Pakes. It's about the breakup of AT&T and productivity. The reason I'm going to start here is because it tells us, well, it's a good start because it tells us both what I learned from this and what we missed as a result of this stuff, okay? And it's what we missed that I'll push on, okay? So you probably, the breakup of AT&T was broken up in 1982 by Judge Green. By 1984, the company had to be split, okay? It was the biggest breakup in the 20th century in America. And it's got very similar things to what they're trying to do to Apple right now, okay? They broke it up into 7 companies. Western Electric was a wholly owned subsidiary of AT&T, okay? It produced the equipment that AT&T used, and AT&T almost bought entirely from Western Electric, okay? For the rest of this, what else you have to know is AT&T owned the landline. There were no cell phones. AT&T owned the landlines and didn't let anybody else connect to them, okay? So what happened, there was 2 stages in the deregulation. And the first stage, which is very similar to what they're trying to do now to Apple, okay, is they said, look, you can connect things to the public system, okay, and AT&T complained, just like Apple's complained, you'll ruin the public system and we put all our money on it. So they set up in 1975 a registration and certification program. Okay, so this program, what it did is it said, you want to put something on the public net connected to the public wires, you go through these guys, they tell you it's safe and you can put it on. It's just like, you know, the iPhone. Okay, it's exactly what they're trying to do with the iPhone right now, okay? And then the question was this a good thing or a bad thing? Okay, they broke up this major company into 7 Baby Bells. The Baby Bells, it was illegal for the Baby Bells to own an equipment manufacturer. Okay, this was in Judge Green's comment, okay, for exactly this reason, okay? Consent decree was it. So I'm going to do the very simple thing for a second because it teaches you taught me something, okay? I'm going to, PT is productivity. It's a share weighted average of the productivity of the individual plants, okay? And you can just write it as average productivity of the plants and the covariance of productivity and share. Okay, so that's in that paper. It's been used 1,000 times. I don't know, 1,000. So this is what happened, okay? So 2 things, okay? First, you see that once you started the registration and certification program, productivity went up, okay? It goes up until 1980, then it starts going down, okay? But remember, 1982 or end of 1981, beginning of 1982, that's when they forced Western Electric to shut its plants, okay? So there was a lot of reallocation going on between 82 and 84, and it picked up again. The other thing you see that everybody picked up on was, it was really, this was a regulated industry, okay? So as many people would argue, capital is misallocated in a regulated industry where there's a rate of return on capital that's allowed in it. Okay, and you can see the capital is actually negatively correlated with productivity. Okay, and this is, so what was going on? It's pretty easy. AT&T was buying from Western Electric. Western Electric had no reason to do innovation of any form or not. Okay, and so that went up. But the thing I want to point out to you is the correlation does go up in the right way. Okay, but the thing that's sort of interesting is the average productivity actually goes down. Okay, so this is a period where the telecommunication equipment industry was flourishing. There were new cell phones, there were new, other ways of connecting. It was just everybody thought technical change was going, through the roof. Okay, so what happened? Why is this going on? Okay, but it's actually pretty easy to know what's going on. Right after the breakup in 1882, Ericsson, Northern Telecom, and Hitachi came in and with digital equipment instead of analog equipment. Okay, prices went down. Is that clear? And so what are we doing with productivity? Well, productivity in these models, and not only mine, but is prices times quantity divided by an index of inputs. It's that index of input that you're estimating. It's the production function. Is that clear? And what happened is these guys came in and prices went down. Okay, that's not necessarily a bad thing. Is that okay? So there were two things I learned from this. One, and this is was very clear in the data. Productivity, firm growth, firm exit, and firm decline, they're hugely correlated. You take revenues and you divide it by an appropriate index of inputs, and you have to worry about the things Richard was talking about. But once you do that, they're hugely correlated. You can't miss it in the data. Okay, but that doesn't tell us anything about welfare. Okay, because welfare isn't price times quantity divided by an index of inputs. Is that clear? So that's where, now I'm going to start on where I went after that. Okay. So why couldn't we delve deeper? We had to have, I just said that. So there are some things that sort of happen. There's a few instances where the measures of price and quantity have become more available. Remember, almost every firm in the United States, certainly all the big firms, are multi-product firms. You get revenue, you don't even know what product it's for, never mind anything else, okay? So still, by the way, the productivity and entry and exit and growth, it's very correlated, okay? So, if you get narrower data on price and quantity, you do better. There was an attempt to go directly to markups. These results are being questioned, but either way, they lack an understanding of what generated the markups, okay? And that's what I need to do counterfactual analysis. Okay, so really, there hasn't been much. So what was the problem? The dynamic models that were available were demanding, okay, in two ways, right? Even if you knew the demand and cost system, say you use BLP or all you pay, whatever you're going to do to get demand and cost functions, okay? The cognitive abilities, the agents making the decisions that you're assuming agents to make, they're just impossible. They're impossible for the best computer in the world, and they will be for the next 50 years. To compute a Markov perfect equilibrium, believe me, I've tried, okay? You can't do it for any sizable market, okay? And neither can the people making the decisions, okay? So what happened is it led empirical researchers to simplify in ways, and that's fine. It was probably the best thing they could do at the time, okay? You shouldn't get me wrong. But it made it harder for policymakers and other people to believe it, because they looked at the assumptions. Those that were smart enough to figure out what the assumptions were, they didn't believe them. Okay, and it was just too. You have to simplify in order to do anything. And I honestly think that much of the work was the best that was possible, given what was known at the time. But people in positions of power did not believe it, largely. Okay. So how do we go from there? Excuse me. So, Welfare needs demand and pricing equations before we go to the dynamics. Okay, so I'm not going to talk. The different product demand systems helped a lot for IO. Okay, I'm not going to talk about it. I'm going to assume you guys know this stuff. Okay. Just an indicator of success, which will tell you, I not only need demand, I need the pricing equations that come from it. So I'm going to give you an example of what works and what doesn't work. Okay, on this. Okay, so I'm going to take Tom Ullman at Chicago's data on trucks. He had a terrific demand system, which he estimated separately without a pricing equation. Okay, on trucks. So what does a pricing equation look like? It's price on marginal cost plus a markup term. The markup term is competition. It represents competition. Okay, and you have to instrument the markup term because your markup will depend on your product and observed productivity and stuff. So we did that, okay? And this is what you get. And this is a very well-defined market, by the way. You get R squares of 0.86 for without time dummies and 0.94 with time dummies. That's a huge R square for a behavioral model in economics, for a social science behavioral model, okay? But that's, really what's impressive is you're taking the markup down from the demand system. It's estimated somewhere else entirely, okay? It should have a coefficient of 1, okay? That's what the theory tells you, okay? And you get a coefficient really close to 1, no matter how you do it. Okay? It's not perfect, but it's pretty close. The other thing is sort of interesting. So what's that saying? That's saying competition really matters. Okay, and when you just fix the car, so you fix the characteristics of the car and just look at the prices of the car over time, the only thing that really comes in is the markup term because the characteristics of the car are constant. And you get an R squared of 0.5 just from the markup term. So there's a sense in which this works, okay? But, we stopped there and everybody patted themselves on the back, okay? And then we started doing more complicated problems, and we know nothing about how pricing fits in these more complicated problems. So in bargaining models, which, Ali Raku sort of started, and he was my student, so I think a lot of them, all of these models, all the bargaining models, the model is designed so prices fit perfectly. That's how they're designed. There's no question of how well the prices fit. Whatever is required from epsilon is required. Okay. Similarly, and we're going to get back to this for forward-looking prices, we have very little knowledge of those prices. Why do I say this for dynamics? Because if you change investment or R&D or advertising, prices are going to change. Okay, in response to that, you expect that to happen, right? The characteristics of whatever you're producing have changed. You expect to price it differently. Okay, but we don't really have pricing equations for many of these markets, especially for changes in prices over time. Okay, so that's going to come back to haunt us. Okay, so that's actually going to be tomorrow. Okay, and today I'm going to do consumer dynamics. By the way, questions are fine. I should have said that earlier. Okay. Okay. The one thing that's changed a bit more recently in data is that we're starting to get dynamics on panel data as choices of individuals, discrete choices over. So it was used in the paper just given, okay, and it's become much more available. So again, the good results on data are not on the dynamics; they're on the cross sections in a given mark. Okay. I want to distinguish between two situations. One where the decisions are closely tied. I make the decision thinking explicitly about future outcomes that are going to come from it. These are like investment decisions by firms or individuals. It can be either. There have been many advances here. I'm not going to focus on this. Okay. The first papers are by Bob Miller and Ken Wolpe, and then there's a paper by me and a paper by John Rust. This is the one Richard referred to. John's paper is a framework that's been used multiple times since now, basically because he doesn't have zero correlated unobservables, but and that makes life easy. But it's been very effective. Let me just say that. Okay. I want to not talk about that I think we more or less know how to do that. Okay. I want to talk about decisions where the implications of that choice can either easily be reversed. Okay, so I make a bad choice, I reverse it. I can reverse it if something happens wrong. Okay, or the cognitive cost of figuring out what a new choice is rivals the utility change from the two things. So you might think this is just marketing stuff, but I don't think it is. So health insurance. Okay, this is a big deal. Okay, health insurance. If I get really sick, I can switch my health insurance in the United States. Exactly. And figuring out what's in each health insurance package and what changed this year is very complex. So that's going to be my empirical example today. Okay. So what happens with models like that? They're more, you can call them, I guess, they used to call it switching costs. Today they call it inattention, not rational, just inattention. Okay. And the thing that's strong about them is they lead to a direct dependence on past choices. Where I was before matters for what I do today. Okay. So I need a model that for demand that conditions on both the determinants of preferences and on past choices. So what's the issue? Some of the determinants of preferences are not observed. Okay, so they're in your error term, and they're reasonably stable over time. Okay, at least over short intervals. So we put past choices into the model. Okay, they're going to pick up the impact of these preferences that are serially correlated, or okay, and not just the impact of switching costs. Exactly. And as a result, the other coefficients will be biased. So, when you want a price effect, which has been a big deal in the American health insurance market, there's been a lot of argument about and a lot of money poured into giving people information because they think they didn't know what was in this and all of that. Okay. So when you want a price coefficient, you want a price coefficient conditional on preferences, which include the preferences that you don't observe because you're not the econometrician, because they're not in the econometrician's data set. Exactly. So the real question is, are you not moving when a price changes because you like the good or because of inattention of some form? And that has policy implications. By the way, this question goes back when I was a student. The same question was in labor economics, and the question was posed as follows. People who are unemployed today are likely to be unemployed tomorrow. Is that because they're unemployable? Okay. Or is there a causal effect of being unemployed today on the probability of getting a job tomorrow? Okay, it's exactly the same question. And it was asked many times before. And the reason we can do it now is not because, we're smarter than the people before. It's because we have moment inequalities and you didn't have them before. Okay, so I'm going to show you how to do this, and I'm going to give you an empirical example. Okay. Okay, I think I said this stuff. Okay, there's going to be a little bit of algebra, but I think the intuition that goes with it, well, if you want to gloss over the algebra, I hope the intuition goes with it. So I'm going to make individuals are going to be indexed by I. Their choice is going to be indexed at time t. And the utility of individual I choosing D at time t is minus the price coefficient. So the price coefficient is beta I because you just move it inside, okay? Minus the state dependence coefficient, where I was last year, the inattention coefficient, if you like it, okay? And that gets a coefficient of kappa 0. So kappa 0 here, okay, is really relative to price. It's how much I care about staying where I was relative to price, okay? And I'm going to assume beta I is 0. And the structural part is everything but the error. Okay. The lambda di's are individual and choice-specific fixed effects that I'm not going to make any assumption of. Okay. So they can be whatever they are. They can differ by individual. They can differ by choice for an individual, whatever you like. Okay. The observed choice is going to be YIT. And here's the assumption that's going to make this work. And I'm going to tell you about it in a second. I'm going to assume that the distribution of epsilon dit, the vector, of epsilon dit at period t is the same as the distribution in every period. This should be a 1, sorry. Okay. So if you're going to use logits, it's the same logit in every, the distribution of errors is the same. They can be freely correlated. You can be BLP, and they can be freely correlated across choice, but just not across time. Okay. Yes.
Do you see the fact that the coefficient on price and on the it's beta I and on the past behavior is kappa not times beta I as a restriction or something else?
The additivity between the two.
The coefficient on the indicator for y t minus 1 is a multiple of beta I, which is the coefficient on p.
No, I'm going to relax that. I'm just going to do, you'll see, this is going to be relaxed. Okay, what is, by the way, it's got to be that you'll see from the logic, I'm going to assume that the fixed effects are additive. That does matter, okay? Okay. So let me say that no serial correlation, Jack and I have a paper, it just came out, which does exactly the opposite. It says, look, there's no state dependence. It's all serial correlation. Exactly. So what I'm trying to do here is load it all on the state dependence parameter. So, is that clear? I'm just pushing all the time dependence on the state dependence parameter because the epsilons are IID. Okay, good. So here's why it works. Okay. Say I chose D at period T, and at some other time S, I chose C. So I switched choices. Is that clear? What do I know? Well, I know that UDIT minus UCIT was greater than 0. And UCIS minus UDIS is greater than 0. Is that clear? Okay. So, if you add two positive numbers, you get a positive number. Okay. So if I add these two numbers, what happens? Well, if I add these two numbers, the fixed effects go away. Now nothing depends on the fixed effects anymore. Is that clear? And moreover, I'm going to be non-parametric on the epsilons, so I can divide through by beta I and just get another non-parametric function. Is that clear? So the only thing that matters is the double difference of the prices and the double difference of the, okay? Good. Okay. Again, I'm going to make kappa a function of x. Okay, I'm going to do that. Okay, so if you just rewrite that as double differences, you get this equation. Okay, it doesn't have any lambda i's in it. Is that clear? And it doesn't have a beta I in it because I've renormalized by beta I. Okay. So the question is, and that, so the question is that the comparison of these double differences in price to the double difference in where people were, okay? And the error probabilities. Okay, so now let me give you the intuition. The error distribution in period T is the same as the error distribution in period S. So if this thing says that you should prefer the probability of D in T is greater than the probability of D in S, is that clear? The errors can't change that because it's the same distribution in the two periods. I'll be more formal about that in a second, okay? So I'm going to let that be that's the structural part of utility. Okay, so now let me be formal for a second. D1, I'm going to say that's the choice. Okay, fix kappa. Okay, I'm trying to estimate kappa. For any given kappa, fix it. Okay, and then for that kappa, look at what's the biggest, the choice that had the biggest difference in utility between period T and S. Okay, I can compare fixed kappa, I can compare the utility at T and the period at S. And one of those was going to be the best. Okay, I'm going to call that D1. Okay, similarly, I can say, if I throw that out, what's the biggest second choice? I get D2 and D3 and D4 and so on. Okay. So seeing the distribution of the errors are the same, it must be the case that the probability of choosing D1 in period T must have been greater than the probability of choosing D1 in period S. okay, for the true kappa, but not maybe for other kappas. Is that clear? That's what's going on. In fact, you can generalize this, and we do in the paper, and there are formal proofs. This is a paper, I hope I said this. Wait a minute, let me just go back for a second. Yeah, I did say Pakes Porter. This is with a co-author. So Mark is a healthcare economist, and Jack's a better econometrician than me. So you can generalize this. And I said the probability of D1 is greater in T than S. If you take a couple of the first two choices, the best choice and the second best choice, the second best difference, then the probability of the couple has to be greater in T than in S, and so on, okay? So in words, if every D in D0 improves more than every C that's not in D0, then the probability of D0 in T has to be greater than the probability of D0 in F. That's the theorem. First, the probabilities still depend on lambda I and beta I, okay? And those, there's one of those, there's a vector of those for each individual, so I can't estimate them all. Is that clear? Okay. But what I know is there's a kappa, say I was a D01 last time. Then I know there's a kappa large enough so that I'm more likely to choose D0 in period T than I had in period T minus 1, because there's errors also. Is that clear? There's a kappa large enough that induces me not to switch. That's all. That's the only argument, okay? So that's true for every individual. Multiply both sides of that by this, okay? So then I get this inequality. I know that when I multiply this side by this, I just get the joint distribution of YIT minus 1 and YIT. Is that clear? And when I multiply this side by this, I just get the squared number, okay? So that's true for every individual. If it's true for every individual, it's true for the expectations over the beta I and lambda I of the individual, because it's true for everyone. So it has to be true for an average. Okay. So that's that. And what's the advantage of that? I can measure this probability. Okay. Now I go to this, and I know from Jensen's inequality that the probability of the mean of the variance of this has to be greater than the mean squared. The variance has to be positive. That's all it's saying. Okay. So I have an inequality which says I know for kappa high enough okay. So if the true kappa is high enough, then this inequality must be true. And these are things I can measure in the data. Okay. For the next one. So what's the content of this inequality? What is it saying to you? It's saying, well, look. So whether the probability inequality holds, oh Christ, I'm going the wrong way. Sorry. Whether the probability holds, it's just a function of the data. I'm going to look at the probability of doing something in period T and the probability of doing something in period S. It has nothing to do with the model. Okay. Okay. So I know if it's a true kappa, I know that it should hold. Okay. So that's what's called the positive result logic, okay? What's the contrapositive result? The contrapositive says, if P implies Q, then not Q implies not P. Everybody in the British school system knows this, I think. Kate Ho taught it to me, okay? So say that, so if I get a contrapositive, that is, I find a kappa, okay, that I find a probability that changes this inequality. So the probability of D in T is less than the probability of D in T minus 1. I know there's an upper bound to kappa. Okay. And similarly, I'm going to get a lower bound. Now, okay, so it's linear in kappa. Okay. So if I get something that negates it, that I get my counterpositive, okay, I'm going to get an upper bound. Oh, and if it's on the other side, I'm going to get a lower bound. So that's the logic, okay? And the only thing I'm going to do to extend that is I'm going to let kappa depend on X, but I'm going to spare you the equations, okay? Okay. What's the logic of the upper bound? I already said it, but I'll say it again. Take a group of agents to start at C and T minus 2. Is that clear? Okay. Say the price of C goes up and some of them switch out. Okay. And then we know that for kappa large enough, those who switch out should stay out. Say for a particular value of kappa, they didn't stay out. The probability went down of that group. Then you have your contrapositive. You know kappa is less than that kappa. And the logic of the lower bound is just equally simple. It says, say I start at C and T minus 3. People choose C and T minus 2. Okay. Then the price of C goes up and people leave. Okay. But in period, that's T minus 1. But in period T, the price drops to a price lower than it was in T minus 2. But they don't move back. That gives you a lower bound on kappa. Okay. So I can show you this mathematically, but that's exactly what happens. Okay, good. So this is the theorem. It's just a generalization of that. It works out that it's different if S is T minus, if I'm looking at comparing T to T minus 1 or T to T minus 2 or something less than that. And the reason is if I compare T to T minus 2, it depends what happened to T minus 1. Okay, so this is just a theorem, but it just says, look, for T and T minus 1, just any of those sets works. The D0 sets works. And for when it's T minus 2, I have to worry a little bit about what I have to make sure that it's true for also any T minus 1. That's the theorem. Good. Okay, back to empirical. So again, that's a good point. So I'm going to try and look at as short an interval as I can. Why? Because I'm doing a fixed effect. People probably forget this, but I'm doing a fixed effect. But when fixed effects were introduced, it was to look at differences in the farms in one period. Okay, so that productivity of the farm didn't change very much. Okay, that was the argument. Let me say the other thing I should say about this is you've seen much of this before in continuous time. So all I'm doing is really put in fixed effects. Okay, so if you had continuous left-hand side variables, you do within and between, right? We do this in all of social sciences. The within regression, what happens to a person over time or firm over time, is very different than the differences between firms or people. Okay, this is the same thing. Okay, only it's done with discrete choice instead of with continuous choice. Okay. Okay, so again, one of the things, so now I'm going to go empirical for the rest of the talk, or maybe not quite the rest of the talk, because I might start the dynamics. Health insurance. So health insurance in the United States has been a big issue. Largely, it's a huge industry, but largely, I guess I should say it. Ariel would be angry with me for saying that. Health insurance is one of these basic goods that the government promises to people. We live in contractarian societies where if you join the society, we're going to ensure you have a certain amount of basic goods, a certain amount of food, okay, a certain amount of education. It changes from period to period, but that amount, okay? But one of them is health insurance, okay? So one of the goals of health insurance, the goal of health insurance in the United States, the new stuff, the Affordable Care Act. I don't know how much you know about American, but there's separate insurance exchanges for poor people. Okay, this started in Massachusetts with what's called Romney Care. Romney is the Romney that you know about. Okay, Romney was a Republican, but it was it stopped Care, which was Romney Care, stopped because Obama put in the Affordable Care Act, and he based it on Romney Care. Okay, so the Affordable Care Act is insurance for people who earn less than 3 times the poverty line. If you earn more than 3 times the poverty line, you can't use the Affordable Care Act exchanges. Okay. So again, there was a real worry in the country that people were not choosing the right insurance programs. When prices changed, they did move accordingly. Okay. And one of the things they did in the Affordable Care Act, by the way, is the exchange, or in the Romney care at least, the exchanges had to give exactly the same prices and exactly the same programs of care as all of them, and they were public. Okay. What did change between the exchanges is the networks and the prices. The networks of hospitals and doctors you could go to, and the prices. Okay. Okay. So that's pretty cheap. So it's 35,000 maybe now. You have to have less than that. So the data is 4 years, and then in 2014, the Affordable Care Act came in. Okay. It's in 5 regions and 5 income groups. We want to estimate switching costs that are not induced by a change in the agent's physical environment. I really want to do I want to condition on everything else. Just by prices, and we require the same choice in both periods for that reason, okay? So we drop all individuals who change regions or face different plan offerings in the years we compare. So I'm not even going to look at them, okay? And I'm also going to, one of the plans, network, drop partners in the middle of this. So I'm going to split it. Partners is the biggest, probably the most famous health system in the United States. It has MGH in it, Dana-Farber, all of the big hospitals. So that's a big change. Okay, so we split it into a network before and a network after partners. Okay. There is an enrollment period every year, and that's the one we're going to use. So here's what we're going to do. We're going to divide this data into cells defined by the Cartesian product of a couple of years, region, plan availability, prior choice, and income group. I should have said this. The income groups, what you had to pay to get the plan differed by your income group. The people with less than 1 times poverty didn't pay anything, no matter what plan, at least at the beginning. Okay, and then between 1 and 2, you paid something, and between 2 and 3, you paid something. So what I'm going to do is I'm going to analyze switching costs within each cell. So all the people that are in a cell have the same observables. Okay, but that's not what's going on. And then I'm going to take a weighted average of the cell inequalities. So if you sum 2 inequalities, you just get an inequality. It doesn't change. And so that gets 312 groups, where a couple of years income and prior choice. Prior choice because we wanted to see the effect of prior choice. Income because we wanted to see the effect of price, and income is the thing that reacts mostly with price. In a couple of years because prices changed over years. Okay. Okay. I'm going to use the moments that are close. So for an upper bound, I need 2 choices, t and t minus 1. So I'm going to just use t and t minus 1. Again, I want to minimize the distance. And for the lower bound, I need 3 choices. So I'm going to use 3. And then I'm going to extend this and show you how kappa changed with observable characteristics. Okay. So, we're particularly interested because it's a public policy thing, the income and the health status of people. That's what I'm going to let it condition on. Okay. Here's the summary statistics. I'll show you in a second why we're going to use the n equals 50 sample, but I thought I'd put both of them down. I'll show you why in a second. You can see there's a lot of people. There's 158,000 people. Yeah, is the total number of people that we're studying. Okay, this is a price. So again, we're looking at movement in prices and how people respond to that. So you can see there's actually a lot of movement in prices. Okay, there's a particularly large movement in 2012. Okay, and you're an IO economist. The first time I gave this, John Russ was in the audience, who is an IO economist, I guess. And he said, well, what moved prices? That's the first thing. Why do we have endogeneity at BLP? Because you're worried about what moves prices is in the unobservable. Here's what happened here. In 2012, the government changed the rules of the game. That's the only thing that changed. And the rules of the game changed in this way. They said, look, the poor people with below 1 times poverty, okay, they used to be able to go to any plan and not pay anything. Okay, now they can only go to the 2 cheapest plans and not pay anything. Is that clear? So that's a big change, okay? The people who were grandfathered in. So if you were already in a plant, you could stay in the plant, okay? Nobody wanted to move people across plants. But the new people who are entering, okay? So, you know, the firms, especially the two biggest firms, but BMC is the biggest firm. These are the purple guy, this guy, okay? And the second biggest problem is network. And they reacted very differently. BMC, okay, when it heard about this, it said, look, you know, the economists have told me that nobody moves. Okay, so I'm going to forget about the new guys, okay, and I'm just going to keep the old guys and move up their price. They're going to harvest. So, okay. And network went exactly the opposite. It said, look, I'm going to win the auction. I'm going to get all the new guys. Okay. So I'm going to show you. So keep in mind that the next year they went down, and they went down lower than they were before. Okay. So so what happened? So this is the data that happened. Okay. The first thing to notice, by the way, I should tell you this. So of the 114,000 people who were enrolled in 2011, only 36,000 of them were enrolled in 2013. So that's independent of where they were enrolled. Okay, this is because that's the way the ACA and Romney Care work. You get a job, you move out. Is that clear? So there's a ton of movement in and out of these things. Okay. Okay. So now let's see what happens when they do the plan. So here's what happens. So BMC, 17%. So 50% are, you know, already in grandfathered. Okay. 17% switched out. And then BMC's response to that, which was the other page, whoops, here, is we were wrong. We screwed up. Okay. We're going to push prices down again. Okay. And they pushed it down lower than their original price. Okay. And so, you know, 11.6% switch back. Out of 16.9%, 11.6 switch back when the prices went down. Okay. It's hard to believe that there's no switching in this stuff. Is that clear? That prices don't matter, that people don't pay attention, at least the poor people in this sample. Okay. Okay, so now I'm going to analyze this and tell you what the switching cost is. There are many ways to do moment inequalities. It works out that the earlier ways, and I'm guilty of this, many people are, the way they do the test can imply negative probabilities, or probabilities greater than 1 or less than 0. Okay, so we didn't want to base inference on that. Okay, so we moved to this other estimator, which is called an empirical Bayes bootstrap. This is not us. We just took it for Counterfactuals and Tamer. Okay. Okay. It's really simple idea. Okay. What you do is you look at the sample, okay, and you do a bootstrap for another sample that looks like this sample. And I can tell you exactly how to do that. You do that 100 times, okay, and you look for the kappas that you accept 95% of the time. Is that clear what's going on? So it's what you really want to do. You really don't want to do asymptotic approximations. What you really want to do is have 100 real samples, not pseudo samples, and figure out what kappa works, okay? So this is mimicking that, okay? The only issue is how to generate the pseudo samples. It's actually pretty easy. You take these random draws from a Dirichlet, don't let scare you, distribution. So this is just a prior distribution for multinomials, but the draws are very easy to take. You just take draws from a gamma distribution appropriately parametrized from your sample. Okay, one from the numerator, one from the denominator. You divide them, and you get a Dirichlet distribution. Okay, so that's all there is to it. Okay, you got to understand the draws in our case are for sequences of probabilities. So I have to start somebody at yt minus 2, see what happens to him yt minus 1, and then what happens to him yt. Okay. So if there are 4, choices, it's 16 probabilities. And if there are 3 periods, there's 64 probabilities. Okay, and I have to sequence it. Once I do that, I get these probabilities. And, I divide by the standard error from multinomial distribution, and then I calculate the set estimator by Euclidean norms. So a set estimate just says, if this inequality is satisfied, okay, it gets a 0. Is that clear? If it's not satisfied, it gets a positive number, okay? And the higher the positive number, the less likely that inequality, the inequalities correspond to kappa estimates. You fix kappa and you look at the inequality, okay, that generates from that kappa. Is that clear? Okay. And you accept or you reject. If you accept the inequality, it gets 0. If you reject, you square it. And then what you do is you look for the kappas that minimize the objective function. Okay, that's all you're doing. So potentially it's a set estimator, because if one inequality, if they're all satisfied for one number, they might be satisfied for an epsilon close to that one. Okay. Okay, this is the answers for the fixed kappa, 1 kappa. Okay, and I'll go more. Okay. Okay. I really wanted to show you this just to show you that this is the reason. So we did it at different sample sizes, okay, to figure out what sample size we got. So we decided to stick with a sample size of 50, but go with a 99% confidence interval because it didn't change. Okay, when we doubled the sample size. Okay, so we figured maybe we were right. Okay. So, this is a pretty wide, this is a pretty wide confidence set, 70, 450. But you should see the published things with this data by Mark Shepard, who knows what he's doing, okay, gives you a kappa of 1,100. Okay, so I'm going to show you what the difference implies between 450 and 1,100. Okay, I want to go a little bit further. This is the objective function, okay? So you see down here, this is the identified set, the estimate. This is where the objective function didn't change when I moved kappa. The kappas, I put 10 and 20. These are per month because that's the way we did it first and I didn't have time to change it. Okay, so the other numbers are per year, per atom. But you could say in this range, okay, there was no change in the inequalities. Okay, and then it goes up and there's a question of when it kills. So these are the 99% confidence interval. You might not believe the statistics, but you got to believe it's less than 50. I mean, the objective function just goes way through the roof. Okay, it doesn't like numbers better than 50. Okay. Okay, so now I'm going to do what you asked for. Okay. So again, this all comes from sort of public policy type things. Okay, so I normalized by letting the price for the lower income group be 1, the coefficient. Okay, and then gamma 2. So again, the lowest income group doesn't pay anything. Okay, the second lowest income group pays 1, and the third lowest income group pays 1 plus gamma. Okay, and if you're not sick, you pay just delta. But if you are sick, SIT. I shouldn't use SIT because I was using it for switching this, sorry. But SIT equals 1 and you're sick. Okay. So I'm now going to turn to the results. These are the results. So I put in also the identified set, but I'm going to focus on the credible set. So we start out with 78,450. Okay. Now let me look at the credible set or confidence set. Bayesian guys call it credible set. You can see once you cut it by income, it becomes much sharper. It really matters. People with lower income move a lot faster than people with higher income. Okay. Remember, this is a poor population. Okay. When I cut it by income and whether you were sick or not, it goes even more down. Okay. So again, it goes, so between S equals 0 and S equals 1, it goes from 408 to 528 to, I don't even get a lower bound and 240. And it's even worse here. Okay. So I think the thing to remember in this is people who are sick, they're losing wealth essentially because they're not able to work. in future periods. Okay, and these are poor people, and they move for small price changes. Let me go on. So I want to do a little bit of comparisons to what's been done before, and then I'm going to go to dynamic games. Okay. I'm going to do logits without fixed effects. So there are a lot of papers doing health insurance with logit without fixed effects. The one I like best is by Dan McFadden and a bunch of his co-authors. Okay. And the reason I like it so much is what they did is they kept on putting in more variables, more x's. Every time they put in more x's, the kappa went down. Okay. So, you could add. So we did that also. Okay. We started with 1,382, and then we did plan dummies interacted with age, sex dummies, interacted with region, interacted with network, and interacted with chronic illness. We got down to 249 parameters, and it was still 1,019. Okay. Mark, in his thesis, did a lot more. He did a lot more data work than anybody ever does. Okay, so he looked to see whether the person had been in one of these one of the network's hospitals before, had the same provider group before, and stuff. And he put in 3 new variables, and they all came out super significant. But the switching variable was still 990. Okay. And you can do, what they do, what a lot of the labor guys do is they add random effects. Okay, initial conditions estimators, or random effects and the first choice, okay, which is a little bit crazy because the random effects should be correlated with the first choice. You can do that here and you get even a larger number, 1,530. It's a little bit unfair because these guys, there are 2 reasons. And first of all, it might take more than a year it might take the first year just to learn, okay, and before you switch. And the second reason is some of these guys were in plans before in their firms, okay, that were the same plans that were being marketed here. So it's a little bit unfair, okay, but there's no indication that, at least in this problem, that would fix things. So these are the actual estimates. You can look at them. Okay. Counterfactual. So what's the question? So does this matter? Does the difference between 450 or whatever it is, whichever one you want to pick, okay, different from 1,000, does it matter for the implications of the model? Okay. So here's what we did. Remember, BMC is the one that went like this and then like this. That's okay. So what we did is we said, well, what would have happened if instead of doing that, instead of going way up and then way down again, okay, it just stayed at the average of the 2 years' prices. So the averages were done by group, by income group and things. So they're a little bit different between the 2 periods, but because they're different populations in the income groups in the 2 periods. Yeah. So here's what happens. In the 2011 to 2012, the price fall from in the counterfactual, the price falls from 97.6 to 70.6. So it's a fall of, I don't know, at least 20%, or 25%. Okay. If you do the model, if you use the model, so how did we do this? What we did is, all we did differently is we fixed kappa in the logit model. Okay, and took it over to the other side. Okay, and then did discrete choice. That's all we did. There's a problem here, and I'll get back to it in a second. Okay. The model without fixed effects gets a 0.03, 0.04 increase in share. Prices went down. 0.03 to 0.04, it's about a 10 or 12% decrease, 10% decrease in share. The model with fixed effects has a 50% increase in share. Now take the 2011 result and say wherever we are in 2011, let's go to 2012. Okay. Remember, as I go more and more years, I'm screwing up more and more because I've got the wrong numbers to start with. Okay, okay. So that's actually a price increase from $46 to $73. Okay. So the model with fixed effects says there's no loss in share. It's exactly the same as it was before. The model without fixed effects is 20 or 25% loss in share, and that's about 60% of the share they had. Okay. Those are big differences. Okay, so Yeah, I don't really have that much more to say about it except for that. So, and these are the actual comparisons. So what do we learn? At least for health insurance, demand models that don't allow for flexible, unobserved heterogeneity generate estimates of state dependence that are way too large and price effects that are way too small. Okay. And when I say way, that's meaningful effects of what you want to analyze. Okay. You know, if you think about it, so you sort of ask some doctors about it, their answer is, well, it's likely a result of specific differences in provider preferences. You know, people like their provider more or don't like their provider more, particularly if you're ill. Okay. And then the methodology, the paper goes into more methodology. It shows you that without the epsilon thing, without the, as long as, unless you have a probability of a double choice was more than 50% of the starting group, you can't estimate it any without this assumption. Okay. If you do have that, and you do have that in most of the marketing applications, okay, because when there's store sales, things go crazy. Okay, then you can do something more general than this. Actually, all you need is the median is 0. Okay, so that's how I was going to talk about this, and I'm going on to market dynamics. Yeah. So questions on this would be good. Andrew, Richard, and then. On the epsilon?
Yeah.
We haven't tested the restriction. Let me just say, I haven't done it yet. I haven't even thought about testing it. I mean, we do, there is the other paper with Jack, which has 3 serial correlation, no restriction at all. Okay, but no state dependence. Okay, so you attribute it all. This is attributing everything to state dependence. On the epsilons, we did non-parametric. I don't know where you want me to go after that. I guess you could have random coefficients and things like that. Richard.
Similar, I think. So you require a minimum number of periods for this.
Right.
And you think people are in and out of very different people. And that, so you lose, there's a set of people in the market who you can't recover your capital for. And that seems potentially quite important. And you might be tempted to look at that's why you might code for covariance that could recognize that. So I was kind of interested whether you could think about, and the way I was thinking of, if you move to another period, kind of add one more period in, you should
be able to
the criteria is it should stay pretty similar. If they were fixed effects, the model should stay in place. And you could see how they're changing. It just worried me. This is a very fluid market. We showed that people coming in and out and switching plans. So you could have switches. You could have them in for a while. It's that kind of restrict set of cabinets you look at.
So the way we're trying to do that, and I'll come back to your question, is we have these fixed effects, which give people individual taste for this thing.
Yeah.
And we have the state dependence parameter for where you were. I think the thing we could do is we could look at another 3-year pattern and compare what we get from another 3-year pattern from this 3-year pattern. We haven't done that. Actually, initially we started doing like all the years. It got to be a huge amount of moments and stuff. That's it?
I wonder, so you had the load, it's going the opposite way of what Andrew suggested.
Yeah.
So you did the load sheet for see what happens. You added the random flags. If you only had a binary outcome, you could do an array if you see those.
Yes.
The reason why you don't do that is because of multinomiality.
There's 2 things. One, they only do binomial. Okay, and then the other thing is they throw out all the data because they need these particular switches. If you go back to, we actually tried this and we got down to like 50 people. And it was just too much. That's it. You guys want to listen to dynamic games for a while? I'll give it a start today and more tomorrow. Okay. So I'm going to now do market dynamics instead of individual choices. Let me say the individual choices, again, in order to do market dynamics in markets where their state dependence or any other form or durability or experience goods or networks, you have to have the dynamics of how people respond, because that's how prices are going to be set with that in mind, okay, if they're state. So that wasn't just, my motivation for that was largely market. So health insurance is a good example. Okay. I'm going to assume demand and cost functions are known. Okay. Now, okay, that's what we did before. I'm going to assume they're known. So I want to now take a step back and look at why maybe market dynamics hasn't done so well. Okay. So there are two real assumptions in what's been going on in market dynamics. One, that state variables evolve as a Markov process. Okay. And fundamentally, it doesn't matter if it's first order, second order, or third order. Okay. And it's a very tractable assumption. It fits the data pretty well. And except for cases where there's non-stationarity in the transition probabilities, which you might have to build in, it still can be Markov, but I'm not going to allow for non-stationary transition probabilities right now. Okay. I will show you that it's easy to fix up part of it, but not all of it. Okay. So that's one assumption, Markov. Okay. And the equilibrium is some form of Markov perfection. What is Markov perfection? No agent has an incentive to deviate at any value of the state variables. Okay. And it doesn't matter what we're choosing. Okay. The perfectness assumption, which is the second assumption, required agents to access a lot of information. They had to know all the state variables of all the agents, okay? And then compute an unrealistic number of strategies. So, if I have 10 state variables and they each take 10 places, it's 10 to the 10 strategies. And they have to compute them for places where they've never been, parts of the state space that they've never visited. Okay. You can get rid of part of this to access large amounts by saying there's asymmetric information. So I don't know all the state variables. I make my decision just based on my state variables. But if you keep with the perfectness assumption, okay, you're going to get Bayesian perfect equilibria. And Bayesian perfect equilibria, if you thought Markov perfect was hard to compute, you should try and do a Bayesian perfect equilibria. And the reason that it's so much harder is because I have to make sure that my perceptions of the probability of what my competitors will do are consistent with what he's doing at the same time as what I'm doing. And it's, you can try a 3-state system and you'll be there for a week before you get it right. Okay, it's just very, very difficult. It's much more difficult than Markov perfect, much more difficult, an order of magnitude more difficult. Okay. So those cognitive requirements, okay, led to doubts about the model's ability to mimic behavior. So that's what I was saying before, okay? And led to implementation problems for researchers. If you were going to try and do this, you want to try and approximate things, approximate like the industry acts, but you can't really do it, okay? These problems can show up in dynamic single agent problems, but the IO was concerned with the market interactions between different agents. So you have to keep the different agents really separately and interacting differently. We want to know what product is competing with this product, okay? And it just became much more difficult. So there were two types of responses in empirical IO literature. So both were sort of helpful. You shouldn't get me wrong, I'm not trying, but not really adequate for counterfactual analysis. The first, what most of what's been done is people focus on what I call unilateral effects. One firm changes, or you changed, one firm stops advertising, everybody else keeps advertising. What happens? Okay. Clearly, that's not an equilibrium response. Everybody's going to stop advertising. Advertising is going to be my example. Work with Pierre. Okay. And then the other one was use approximations. The problem with so that's by Ariel, and Levin, and Pakes, Ostrowski, and Barry. I'm not trying to get myself out of this. Okay. The problem with that is you're doing the approximation for the current data set. Okay. And then you're going to compute the equilibrium with that approximation for a different environment, the counterfactual environment, which isn't in the current data set. Okay, so the approximation, even if you were good at approximating, I think it's very hard to approximate these things, by the way. You're not going to get it right. Okay. I don't want to say, so both of these things, let me just say that they taught us stuff. Okay, so I don't want to, but they never got really to counterfactual results. So, it's not just applied people who knew there was problems. Okay. Theorists were well aware of the cognitive problems. There's a huge literature in theory about these cognitive problems. Okay. Mostly they did one of two things: either weaken the notion of equilibria, and by weakening the notion, they decrease the cognitive requirements. I'll show that in a second. Okay. Or they used a learning process instead of an equilibrium model. They said, look, forget about equilibrium. I'm going to just show you how firms learn, and we're going to go along places. And if it stops somewhere, it's going to stop at a fixed point because it's going to stop at a Nash equilibrium. Okay. So the examples that are, the examples that are most known to me, maybe there's more examples, okay, is Fudenberg and Levine. They did what's called self-confirming equilibria. This just says that off the equilibrium path, okay, I know I'm doing the right thing when I choose what I do choose, but had I chosen something else, I don't have any requirement on that. Okay, so that clearly, okay. Osborne and Rubinstein, they do this procedurally rational players. What they do is they say the players are playing an equilibrium. I don't know how they got there or what they computed or anything else, but it's an equilibrium. You condition on yourself. It's going to be very similar to what we do, by the way. But I'm not going to tell you how there's a learning model or whatever. And I'm going to look at the equilibrium and tell you what its properties are. Okay. And then Espondo and Puzo, they do something called Burke-Nash equilibrium. This is equilibrium with improper priors and learning. And what happens, improper prior mean the prior on the parameters of the model don't cover the true parameters. So, and they show that you would converge if you did a standard learning model, converge to something very close in a particular metric. Okay. So, I'm going to end up using all these ideas. Okay. But let me say the difference between what I'm going to do and what they did is these papers all considered games that state variables did not evolve over time. They're theorists, and what they wanted to learn was how I reacted to my neighbor's choice. Exactly. I wanted to know how I formed my perceptions of what my competitor did. Okay, but the state variable was a repeated game. The state variables were the same. All of these papers are like this. Okay, in one form or the other. Okay. Okay, so the problem, of course, is, oh, by the way, there's also an empirical literature on learning, and it was also like this. It's a very, I wrote one of these papers. It's a very seductive thing, right? You have an environment which is essentially constant over time, and you watch how people change in response to how their competitors change. Okay, it's a clean way of looking at learning. Is that clear? It's clean, and that's very nice, but it lacks the dynamics and payoff relevant variables in either demand function determinants or cost function determinants. And all our investment theories, R&D, advertising, physical investment, doesn't matter what. It's all about investing and the changing of state variables. Okay, so it couldn't directly be used. And yeah, finally, Chaim Frischman, I talked to Chaim long enough that we figured out a model way to incorporate these ideas into a dynamic game. Okay, Chaim is a theorist at Tel Aviv. So I'm going to begin with the theory and then go over an empirical example. Okay. The analytic framework has two parts, right? One is a notion of equilibrium. What is an equilibrium in this context? And one is a learning theory that can get us there. Okay. So the equilibrium strategies are rest points to a dynamical system. What's an equilibrium? I don't want to change. Okay, everybody's doing the best they can given what they're doing. So it's a rest point to a dynamical system. Okay, so we need a Nash condition of some sort in order to generate this. So here are the conditions I'm going to use. First, perceive that they are doing the best they can. They're going to, they need not be doing the best they can, but they think they are. Okay. And these perceptions are at least consistent with what they observe. They don't observe something, okay, which contradicts the perceptions. If that's true, they change their perception. Okay. So those two conditions are going to be equal. I'm going to do learning too. So, but these now are the equilibrium conditions, okay? Maximizing behavior. Agents choose actions which maximize their perceptions of their expected discounted value, future net cash flow, conditional on the information at their disposal. So each one can have different information sets. They don't need to be the full Markov stuff, okay? But conditional on that, okay, they're going to think they're maximizing, okay? And then partial consistency of perceptions. Their perceptions need not be correct, but they are consistent with what they observe. And that means that in the limit of these, and there's a problem about limits, and I understand that. If a state is visited repeatedly, we're playing equilibrium, and if a state is visited repeatedly, it means that I can see the distribution of my outcomes from profits and where I go next. Is that clear? There's an empirical distribution which I can use. So if a state is visited repeatedly, in the limit, I have them correct. Okay. So different agents can have different information sets. So that's asymmetric information. I'm going to go one more step. And the theory doesn't, but the theory does not constrain what they contain. Okay. So all the theory says is you're maximizing given your information set. It doesn't tell you what that information set is. Okay. That's going to be the problem of empirical work. Empirical work has to determine what that information set is. Okay. And I'll get to that. This is going to greatly reduce the cognitive requirements, but it still has a perfectness assumption just on a reduced state space on these points I hit repeatedly. Okay. I should stop here because I'm going to do formal stuff now, and it's almost 7:30, and maybe we should stop. Is that fair enough? I'm happy to take questions. I'm going to pick up here and show you how to do it. Hopefully, show you a learning model that gets you there, and then I'm going to go to the empirical example with Pierre and show you how we implement. That's tomorrow. Sometime. I'm happy to take questions. Yeah.
Oh, yes. We hopefully, if you say okay, with the pointers, we can have some cocktails. And I hope to see you all tomorrow here.
Thanks for coming.
Always be looking at.
Yeah, I didn't pick up on it. I didn't pick up on it.
I actually do have a question, but I didn't want to ask you, like, I was 5 minutes late, so it's possible you answered it before I arrived. So it seems to me that the sometimes just sort of taken away from the interpretation way of switching. Because something that I was thinking is, for example, if switching on due to then the switching cost is partly due to inattention, where people aren't aware that pricing of competitors have gone down. The policy is the guys.
Oh, that's that.
Just to pass.
Right. But the exact nature of that switching costs can have policy implications. Because if it's just a matter of I haven't heard that the competitor's price has gone down, I don't look very often. After like 2 or 3 years of a competitor's price being lower, people might stop the switch eventually. Whereas if it's more than like I have to sign some forms and it's going to be a whole thing, you might never switch.
What I have against people are interpreting.
Oh, yeah.
Yeah, sure.
Right.
The same. What do we know about the fundamental relations between switching?
Not much. I mean, various sometimes we don't figure out what the cost is going. But I think when they do that, you're public. It's got to be. When I know of They get pretty crazy numbers. Or what it would have to be.
Sure, but you want to know, it's 400 instead of that. So I'm thinking if to reduce the switching costs. So that's what sort of tension between the environment is stable.
Yeah.
And me relying on price.
Do you have anything?
variation. As the firm, I know what then it just increases your switching costs. I bombard you with advertising. Yes, choice is much more complex.
Yeah.
And so how close are we to getting sort of a view on what is possible?
I guess the question would be, I guess the way I would do it, and I won't, but I mean, stuff you might do, but the kappa, if you made it a function of stuff.
Yeah,
So, I mean, the thing we did, we were worried about.
It was like,
poverty.
why?
So we made a function of income and health. But you could make it a function of other things.
so that's what I was thinking of Sendel's work, Sendel with Latham.
You know, what is the answer?
That he's basically saying, you know, and lots of people have replicated this, the lower income people have less cognitive bandwidth to make good decisions. So they can afford to pay less attention and are actually, you know, it looks as if they have higher switching costs as you move down the income distribution because they have other things to worry about than working out the exact response here. So that your results are the opposite to that, that the lower income people have lower switching costs because, you know, it makes much more of a difference.
That's fine.
I think it might depend on the income.
Yes.
It really might. I mean, the thing that was striking to me when I saw the ethical zero stuff, when people were saying, you know, they really just moved. You know, I mean, when their income is down, or what their future income is down. They have kids, you know, they, you know, money matters. I don't know how else to think about it.
Okay.
But I do agree that on both of these things, that you could make this much richer.
But it raises, well, I think what you're saying as well raises an interesting question about firms trying to deliberately
Right.
get switching costs by. I guess they don't do this in the healthcare market. In other cases, you literally incentivize switching, right?
So from advertising, so if you look at the old stuff on advertising, now these guys are done. They're really like Dennis Mueller, passed away a long time ago. He has a book on advertising, and the goal of advertising was to change the elasticity of demand. Yeah, that's what he thought the goal of advertising. And you know, there's some truth in that.
Yeah.
I mean, and it does that a little bit, like in PR and their model, because it changes the utility from the good. And that's going to change the cross price elasticity from the good. I don't know if it does it in a way, you know, in a strong enough way. I don't know if that's the right way to do it. Shouldn't get me wrong. The thing about advertising is, you know, in a way, we're doing it in a crazy, including me, okay, yeah, in a crazy way, because we don't really know how it affects things. Yeah, there's a marketing literature which says it affects the choice step. Okay, there's, you know, another literature which says it's informative, it tells you something. There's another literature, there's another literature that said it's because you like Michael Jordan. Yeah, Michael Jordan's on TV, and if Michael Jordan does that, it must be good for me, you know, and that's a psychologist. I don't think we know a whole lot. And it's a lot of money. It's about as much money as R&D.
Yeah.
So,
No, the disconnect between it's important in the economy, understand that it's a bit disturbing, but. And here in the model that you presented, with enough data points, you could test whether cap is the same within the individual over time.
yes.
And are you able to do that?
Well, the lambdas might change also. The fixed effects would change. That's why we took, but one thing we could do, I never answered Richard correct, which I realized afterwards, as Ariel told me, but the, what you could do is you could look at, you know, different, like whether the 3-year guys are different than the 2-year guys. And I, you know, we never did it. We never thought about it, honestly. I mean, we took a long time to get here.
The whole of the room UCL.
It was
Very hard.
Ariel was saying that.
Okay. Which one?